Alright, in this video we are going to talk about composition of functions. And so when we talk about compositions of functions, we're talking about this notation right here. And this is pronounced f of g of x. Another way that we can write that is like this right here. Here we have the same thing, f of g of 2. So instead of having our variable x here, we have a number 2 that we'll end up substituting into our equation. So to get us started off, right here, our first example, we have f of g of x. And so again, what that means is we have f of g of x. And so if you remember back from Algebra 1, we've done things like find f of 4. And what that meant was we took this 4 and we plugged it into our function f. So this is pretty much the exact same thing. Here, instead of a number, we have a function g of x, and we're going to take g of x and we're going to substitute it into every place we have an x in our function f. And so what that's going to look like is here, my function f is 3, but instead of writing x, I'm now going to substitute in my function g. And to finish out the equation f, I have 3 times x minus 1, so you don't want to forget that minus 1. And like I said here, instead of now having this x, we're going to substitute in g. And as you can see, g here is x plus 5. So here is f of g of x, but now I need to simplify. So I'm going to distribute the 3 to both x and 5. So I have 3x plus 15 minus 1. And again, combining like terms, that's going to leave me with 3x plus 14. And that then is going to be my final answer for f of g of x. Okay, now in problem number 2, it asks me to find g of f of x. So what that means now is that we're going to have g of f of x. So now I'm going to take my function f and I'm going to plug it into anywhere I see a variable in my function g. So I have my function g is x plus 5. So instead of writing x, I'm going to substitute in f, and I have that plus 5. So substituting in my f function, I have 3 minus 1. Again, we always want to look to see if this is going to simplify. So we have 3x minus 1 plus 5. And here I can combine my like terms, and I get 3x plus 4 as my final answer. All right, problem number 3. I have f of g of 2. So here, I want to plug the number 2 into my function g. So g of 2 is going to be 2 plus 5, right? Substituting in 2 into the x position. That, of course, gives me 7. But here I have f of g of 2. So now I need to find f of, well, 7. Now substituting 7 into my variable location, I have 3 times 7 minus 1. 3 times 7 is 21 minus 1. So now I have f of g of 2 equals 20. Okay, that got us through our first 3 examples. And so now you can see here we're going to change our equations. And so now I have f of x equals x minus 2 and g of x equals x squared plus x. So we're going to still do the exact same thing. Here I have f of g of x, so f of g of x. I'm going to take g, I'm going to substitute it in anywhere I have a variable in my f of x function. Well, my variable is located here. So I'm going to substitute g into that variable. So I have x squared plus x, and then of course don't forget your minus 2. We always look to see anywhere if it will simplify. We do not have any like terms, so this is my final answer. Okay, number 5, we have g of f of x. So g of f of x. So now we want to take our function f of x and substitute anywhere we see an x. Well, here, my g of x is x squared plus x. But remember, we want to take any place there's an x and substitute in f of x, which we know is x minus 2. So erase the x, substitute in f of x. Again, we need to look to see if we can simplify anything, and here we see that we have x minus 2 squared. So that means I have x minus 2 times x minus 2. Then I have plus x minus 2. So now we need to simplify this, and we're going to simplify this by first distributing. So distribute my first term to my first term, that gets me x squared. First term to second term, that gets me minus 2x. Second term to first term, minus 2x. And then last term to last term gets me a plus 4. And again, I still have this plus x minus 2. So now combining like terms, we have our x squared. We have a minus 2x, and an x. So minus 2x would give me a negative 4x, but then plus x leaves me with a negative 3x. And then my constant terms, I have a plus 4 minus 2, which would be a plus 2. So that one's a little bit more work, but still we're just taking our equations and substituting it in. All right. Last one, number 6. Again, you always want to work from the inside out. So here we have g of negative 1. So I want to find g of negative 1. Well, using my g of x equation, that would give me negative 1 squared plus a negative 1. Negative 1 squared is a positive 1, and a positive 1 plus a negative 1 is going to give me 0. Then again, I have f of this. So now I have f of 0, which looking back at my f of x equation should be 0 minus 2, which would give me a negative 2. All right, you guys should now be able to move on and do your quizzes.